Hi, everyone. For those of you who do not know, my name's Nat, that's N-A-T, and I work at an organization called Exceptional Individuals. We're a neurodiverse organization, so most people in the company are neurodiverse, including myself. I'm also currently doing my master's in neuroscience, and I support people who are ND every single day. So you are in good hands, and we do these webinars every week in order to hopefully enrich people's lives a little bit and take nice complex subjects and make them super digestible and easy for everyone. Because a lot of these things hopefully really can benefit ND people in their day-to-day lives. Okay, so while mostly we focus on dyslexia, dyspraxia, autism, ADHD, the techniques we're going to be learning about today will have really, really strong implications in terms of how they can benefit our understanding of neurodivergence and cognitive diversity. Honestly, they can be used across the board. So we are going to have a hyper focus today on NDs, but honestly, this can work for most people. Now, as I mentioned, our lovely team, we're ND, and we're based around London, but we're kind of remote now, so we work all over. And our last webinar we did last week was on neuromarketing. Now, this was a little bit off subject for us because it wasn't so related to being neurodivergent, but it was an interesting subject nevertheless, because if we can learn more about the brain, we can also manipulate the brain. And it was good to understand about how different techniques and different ways of presenting information can have a massive impact on us. And it was curious to see how that kind of overflows to people who think differently. Does the brain get manipulated in the same way? Are they more vulnerable, or do they not get as affected as strongly by traditional means of advertising? So do check it out if you're interested. Oh, TO says, greetings, fellow humans. Oh, nice. I am RTO. I'm autistic and have ADHD, combo platter. I also have CPTSD and diagnosed with depression. I'm here to learn and possibly take resources back to the staff network that I'm an admin of. Amazing. Great to have you. Yeah, I'm always the same. I feel like neurodivergence is like Pokemon, you got to catch them all. So how do we understand the ND brain? Well, in many ways, it's very similar to how we understand the neurotypical brain because brains are brains. But there are definitely differences in terms of how the brain connects the dots and the information that is processed. So if we know our toolkit, we're able to see what would be the best approach into answer our burning questions. Because we have so many questions, right? Like, why am I like this? Why are other people like this? How come I can do this? How come you can't do this? Why am I really good at this? And these are questions which are really hard to answer. But with the range of tools we have available, maybe they're not impossible or won't be impossible forever to answer. So we are only touching the very tip of the iceberg today. There are way, way more tools, but I just wanted to give you a little bit of a taster on some of the things we can use. Like when we do these webinars, we talk about studies, we talk of facts and statistics, but we never really talk about where these facts and statistics come from and how do researchers kind of come to these end results. That is what we're going to be focusing on today. So what responses are we going to cover? Well, we're going to be looking at behavioral and psychological. So behavioral is how the body responds. Psychological is, what's going up under the hood. It's a kind of a combination. We're also going to be looking at your neural pathways. So essentially one brain connecting to another bit of the brain and kind of going all over. You'll notice that the whole body is interconnected. So if one thing happens in one place, there is some sort of knock-on effect like elsewhere. So for instance, if you are cold, you get kind of like goosebumps. If you are hot, you sweat. These are things that are like a chain reaction. And these chain reactions can be quite obvious, but sometimes they can be really micro. But we can record those micro reactions and they can tell us a lot about how someone is feeling, processing, kind of interpreting the world around them. And we're also going to be measuring in ND individuals. So for instance, when we're looking at eye tracking, where how people's eye responses are kind of tracking like web pages, is it any different in those with autism, considering we know that autistic people sometimes struggle with eye contact? So some of these things might translate, and other these things may not translate so well. Now, first of all, let's start off with some good old definitions. So the father of reactions, I suppose, is Fran Donners. And he was the first to measure reaction times. Essentially, reaction time is just how long does it take you to do something. A good example, if you have a pen and you drop it and you catch it, what is the response time? Do you catch it straight away at the tip, or do you end up catching it later on? And for instance, people with dyspraxia, ADHD, they might have slower reaction times or sometimes faster reaction times. When you drink, you might have slower reaction times. If you've taken stimulants, you might have a faster reaction time. And these reaction times can be motor coordination, like hands. They can also be visual. They could be kind of sweat. For instance, when you're in a sauna, how quick do you start to sweat? It will vary and depend on so many different factors. First of all, reaction. Reaction is a time it takes to respond to a stimulus. Now, again, this could really mean so many things. So, for instance, when you eat a sweet, how long does it take for that sugar rush to hit your brain? If you take a drug, how long does it take that drug to respond to you? If you see a flashing light, how long does it take for your eyes to kind of like go whoop, really big? All these things have different varieties. Then we've got the mental chronometry. So the study of reaction time and inferring content, duration, and temporal sequencing of mental operations in response to a stimulus. Oh, okay, that sounds quite a lot, but all it means is how do we use this information and actually use it for good? So first of all, let's start off with an example. So on this screen, you'll see a light blinking on and off. And I want you to click the little heart on your phone every time the light goes on. And yeah, so hopefully you'll get a bit of a routine up. 1, 2. So this is a really simple reaction time, and this is to monitor your perception of your motor. So you visibly see it, you physically react. Nice and simple, right? And this was one of the first tests done in order to kind of gauge different individuals' reaction times and what is considered normal and what is considered abnormal. Okay, now for a next one. So the next one is hopefully going to be a little bit harder. Now I want you to click the heart icon when the light is on and the little thumb icon when the light is off. Now, yeah, okay, that's quite interesting to see. Now the brain is having to do more computations, and you're able to see not only your reaction time, but also your ability to switch and be a bit more agile. So increased contrast, function available choices. Okay, nice. I can see all going nice and well. So these are some of the really early tests we did in order to monitor understanding the brain and reactions. Now, what are we really monitoring? Well, we're monitoring the stimuli from our ANS, our autonomic nervous system, and these respond to environmental domains. So in our body, we have a load of things which can respond to the world. So for instance, our pupils respond to light, and that gets sent to the ANS. We also got a heart, which, when we're running faster, our heart will beat faster. Our lungs will kind of go in and out more as well. Our bowels will change depending on the food we eat. There are so many different elements that everything is kind of a reaction. And again, understanding these can help us a lot in understanding different mental conditions, responses. So how do we actually measure these? For instance, we know that the eye will kind of get bigger and smaller depending on the light. We know that the liver, depending on how healthy it is, will be able to process alcohol better. We'll know that certain foods go through the body quicker, other foods take longer. Now, these are all known things, but how do we measure them? So, for instance, let's say someone who has PTSD, maybe they get anxious faster and start sweating more. Now, this can be a visual observation, but can we back it up with actual metrics? Yeah, we can. So how do we do it? Well, there's a few different tools in our box. First of all, we're looking at Electrodermal Activity, EDA. And this one looks kind of futuristic, a little bit Iron Man-ish, but nice and simple. The skin's electrical properties respond to the environment. So our hands are sweaty. We don't notice it, but they are. There's lots of kind of electrolytes and kind of salts and sugars and stuff, and essentially a very strong connection. So the sweatier you are, the more electricity your body is making. And there's certain parts of the hand that produce sweat faster. And this can be a tool you can use in many different ways, not just for exercise, but even for kind of more micro things. Maybe you're doing kind of a lie detector test and you're getting a little bit nervous and you start to sweat more. It might only be a very, very tiny difference, but that can be monitored. Maybe you have autism and you get really kind of worried in social situations, and this can monitor your response to different stimuli and different environments. So this does have a lot of potential uses. Now, it's important to know obtaining the data is only one piece of the puzzle. The second part of the puzzle, which is a lot more difficult, is interpreting that data into something meaningful. It's always important to remember correlation doesn't equal causation, meaning just because we observe something doesn't mean it is fact and it is based in reality. Oh, Lucy, can we get a copy of the PowerPoint? No, but it is being recorded, so you can watch it on YouTube. If you really want a copy, let me know and I can send it to you privately. So let's see an example of this. So skin conductivity. So our skin, again, imagine it's just a circuit. So kind of the more sweat we have, the stronger the circuit, the stronger the signal. And these are things that we're able to pick up on. So sweating increases electrical conductivity. Conductivity is essentially how easy is it for electrical signals to flow. Think about it like if you're just out in the open, you're not getting electrocuted. If you're in a bathtub and some electric goes into it, and you're going to get fried. Now, sweat isn't as wet as a whole bathtub of water, but it still does increase it. So it's a very, very similar concept. The more sweaty you are, the more electrical conducive you are. Then we've got the increased lower electric resistance. So all this means is, the resistance is how easy is it for them to go from A to B? So is the circuit getting completed faster or slower? And that can tell us exactly how much you're perspirating, kind of your nervousness, your emotions. But one thing it is, again, important to appreciate that we may assume that, oh, if you're sweating, it must mean that you're nervous. Well, no, it can also mean you're excited or happy. So these things don't always line up completely with particular emotions. And this is assuming that we all interpret the world in a similar way. For instance, some people, when they get excited, they might get sweatier. Other people, when they're nervous. So they don't always work completely. Electrical currents flow easy across skin. So this is a quite good one. And I'd love to know in your own opinions, do you think that this could be useful in understanding ND conditions better? If so, how? Because a lot of these things, we're still kind of learning how to best implement them and to get the most interesting data out of it. So this is quite an interesting one, and it kind of touches upon what I mentioned a moment ago, the pros and cons of EDA. Which image could result in increased skin conductivity or conductance? So essentially, which one is going to have the biggest reaction when you've got a smiley face or a sad face? And you might think that, okay, maybe certain emotions might mean that it's more easier to pick up. So for instance, if you're sad, you might think that there might be a higher sweat context on your body. So it's easy to pick up. Or when you're happy, you might. Now, this is where it gets really, really difficult, okay? Because these tests are really good at determining the frequency of emotions. So for instance, low emotions, it won't pick up. Really high emotions, it will pick up. So it can pick the frequency of emotion, but it can't pick up what emotion. So for instance, if you're really happy, it's going to know you're really, well, it's going to know there's a high emotion. But if you're really sad, it's going to show really high emotion. So it doesn't know if you're happy or sad. It just knows if you're showing an emotion. So again, for lie detector tests, It's interesting because it can tell you when your body is reacting, but it's not able to tell if you're reacting positively or negatively. So maybe these tests are better if you're expecting a more neutral response, but it's not going to give you this kind of like fine detail. So in ND individuals, EDA can show how intense their emotional reactions are, but it can't tell what specific emotions they're feeling. They can make it tricky to understand the exact emotional state. A particular example how this could be implied is when ND individuals, say those with autisms, are stimming. That's when they're moving their body to try to regulate themselves. Often this was considered as a negative thing, but we now know that it's not necessarily. It normally means when the body is being so overstimulated that it needs a way of re-regulating itself. So this could be in a happy environment, the body feels it needs to kind of like calm itself down, or when it's in a sad position. It doesn't matter what emotion, but it just matters on the amount of the emotions. Oh, Lucy, if you could email me, because I will lose this afterwards. And RTO, I think the EDA measurements might back up what we're saying. For example, I tell people that unexpected phone calls make me nervous, and often people think I'm exaggerating. So a heightened skin response might correlate with the response of the experience. Yeah, that's a really good example of how it would. So you're able to take something which is a feeling you have to a concrete example on essentially you're proving it, which can help people have better empathy. Because let's be honest, there's not a great deal of real empathy when it comes to understanding ND responses. Oh, Charlie says, I feel the exact same way about unexpected calls. Yeah, yeah, absolutely. So, what are some pros and cons of EDA? Well, you let me know. So, on this, you either say it's true or false. So, do you think it's inexpensive? Is it cheap? Do you think it can be used in lie detector tests? What about quick to set up, easy to interpret, and is it non invasive? All right, nice. The results are in. Let's see how you all done. True, false, true, false, true. Cool. So, is it inexpensive? Yeah, it's quite cheap to be honest. It's very accessible. It's not going to break the bank, at least for an institution. Can it be used in lie detector tests? No. It can tell you if you are feeling an emotion. It can't tell you what emotion. Is it quick to set up? Yep, really easy. Put it on the finger, you're good. Is it easy to interpret? No. It just tells you, it doesn't tell you much. A good way, I mean, this is a really nerdy reference, but if any of you remember in Harry Potter in the Sorcerer's Stone, Neville Longbottom has this rememberable ball and it will go red every time he forgets something. But he would always say, well, it's all well and good. You told me I forgot something, but you're not telling me what I forgot. And I think it's quite similar to that in many ways. It tells you, yes, you are feeling something, but not what. And next one, is it non-invasive? Which means, do you have to like break or cut the skin or put something in you? No, it can just strap on and strap off. The next one we're going to be looking at is electrocardiograms, or most commonly known as ECG. This is your heart rate. And I've got a little one on my Fitbit right now. And again, it's kind of measuring my heartbeat. And this allows you to view unpleasant stimuli. So if you're watching something that you aren't enjoying, you'll notice that it goes up. If you're kind of calm and chilled, it will go down. And the way they do this, nice and simple, they have little electrodes. These are like little pads that kind of connect to your skin, and they just go there. The electrodes emit heart electrical activity to the ECG machine. So they're taking the kind of impulses from here and they're sending it to the computer. And this will create waves that represents the heart rhythm. So this is something that we've been used for years and years now, and it's a really good way to see how your body is responding. Well, let's see again the pros and cons of this. It's the more kind of common one. So what do you think are the pros to cons of monitoring your heart rate? First of all, do you think it's quick and simple to set up? Then what about, is it comfort when electrodes are removed and needs expert interpretation? So let's see what we've got here. Okay, yes, it is really quick to set up. Honestly, anyone can do it. It's not comfortable when they remove it. So normally what they'll use is kind of like some gel paste, and think about it as kind of like when you're waxing yourself. It kind of feels like that. It's not the most comfortable. So again, if you wanted to use this, say, on someone who had high sensory needs, this may be an approach which, though not overly invasive, might not be the best for them. But this is a very good way to again see emotional responses, quite similar to the skin one, but again, has different uses and needs expert interpretation. Once again, yes. These little lines aren't as simple as having a good time, having a bad time. There's a lot of more nuances, and there's lots of things that can make these readings not as reliable as one would like. Oh, April says, I got the heart rate app on my Apple Watch too. Nice. Oh, Neville forgot what he forgot when his ball goes red. Nice. So another one to look at is EMG, electromyography. This is where signals can be used to measure reaction times and to study biochains. So essentially, every time we move our body, our muscles, it is an electrical response. And there is a way to measure how these muscles are contracting and retracting. So what we do is we use needle electrodes inserted into the muscles. Now, this is a little bit different to the last one we watched. The last one is like a sticker. This one is like a needle. So this is invasive. Not everyone's going to enjoy this. Neurologists, so again, experts, can tell you when to contract and rest the muscles. So going up and down. And the needle records activity during rest and movement. Now, all well and good, but what can this actually be used for? And how might we use this to better understand neurodivergence or individuals in general? So let's look at some of the pros and cons, and this might help us understand where it can be used and where it might not be as appropriate. So EMG helps measure muscle activities in ND individuals through effectiveness and can be reduced by extra fat. So while this is very good in understanding how the body responds, may be particularly good for those who could be having seizures, maybe good for those with dyspraxia and seeing how their body is kind of responding to stimuli. It could work for those with ADHD who have kind of their response rates. But if you've got a little bit too much love handles, maybe it's not going to work as well. So with most things, you have pros and cons. None of these are a complete system. And as always, it gives you data. It doesn't give you the interpretation of the data. Oh, Haley, I would run a mile from this one. Yeah, a lot of people would. When I say like needles, it's normally like a little prick. It's not often like a massive one. It doesn't hurt that much, but it's not for everyone. Quick and easy, no. It takes time to set up because again, you're like, prick, 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 all the wires and cables. This could be one which, if you're trying to measure someone's responses who might struggle in these situations, this isn't going to be your best one. Restricted to superficial muscles. So essentially only kind of like the real big chunky ones with that have like the main impulses. It's not going to be great for these micro responses. And if you've got a little bit of extra baby fat, you're going to get a weaker signal. So this works much better with people who are kind of a bit more slimmer. Moving nicely on, and this one I think has real uses for particularly those who have autism, is eye tracking. And eye tracking just uses infrared and cameras to help understand where ND individuals focus their attention. So essentially, you have an infrared light, which isn't harmful. It goes to the eye, it kind of reflects off the cornea, and it comes back. So we're monitoring that reflection. We're also using cameras to kind of track the iris, your black dot, and how it goes around. Now, this is a useful tool for many, many reasons. For instance, if someone is struggling to learn, well, why is that? Are they focusing on the right context? Because we often know that people with autism struggle with eye contact. But what if they're not looking at the individual, what else are they looking at? So maybe we can kind of understand that. We can also kind of see what people's preferences are. You can see how this has massive implications for neuromarketing. For instance, if you're creating adverts, you obviously want people to look at them. But again, in the education space, you want to make sure that when you're putting your little pictures, are they engaging your audience or are they distracting your audiences? So there's lots of implications for this as well. There is a big downside to this, though. While it can tell you if something is being viewed, it's not telling you if someone is processing it or understanding it. Those are two separate things. Understanding and viewing. Viewing doesn't equal understanding. So here is a great example of how a test was done and what it was able to teach us about how people read. So neurodivergent eye movements can reveal their unique information processing styles. So let's take dyslexia, for example. Someone who doesn't have dyslexia, you'll see how they notice left to right, and they kind of go back and forth, back and forth. But interestingly, what we noticed is people don't read as fluidly as we thought they did. So if you see every time there's like a little blue dot, this is like the eye kind of jittering. So think that the eye goes, it kind of moves, stops. It's kind of more like back and forth rather than being fluid. But these kind of little jolts, we don't notice as much. Yet those with dyslexia, we noticed had more jolts, and they found it more difficult to kind of realign their eyes after kind of recalibrating from these little micro stops. So this can be used to analyze how eyes react to environments. So again, these tests, before this, we didn't really know how people read. And you'll see that like the dots, it's not as fluid. Like some words will kind of make it go up or down. And this varies a lot for dyslexia. Another way that you could use eye tracking is seeing where people's attentions are for images. So on here, I want you to select what is the first thing you see and what is the thing that you see for the longest. Now, I appreciate this experiment is a little bit flawed, but it gives you an idea of how it is otherwise measured. So when you see like these little kind of blotches, the darker the color is where the eye is more focused. The lighter the blue, well, the darker the blue, is where the eye is still focusing, but maybe just kind of glazing here and there. So data can inform which parts of an image attracts a viewer's attention and for how long. Neurodiverse individuals process images differently than neurotypical individuals due to a varied cognitive processing and perspective. So this is one which shows the key differences that being neurodiverse isn't just a made-up thing, it actually is provable. So if you've got two individuals, you would imagine them to kind of see images the same. For instance, one person would kind of see like, oh, that color is attracting me the most, and it would be quite consistent. Yet we've realized it is not. One, it can be due to someone's neurology, different kind of neurological kind of backgrounds, or the way your brain has developed will mean you'll have different areas of focus. Also, kind of culture. Your culture can also impact what you kind of read first. You know, a lot of countries might read right to left or up to down or down to up. And these are things that we don't always take into consideration. So you've got the classic nature v nurture and nature. So what are the pros and cons of using eye tracking to better understand human mind? First of all, is it non-invasive? Do we have to do anything which is going to like hurt us in order to use it? Secondly, is it relatively expensive? Do you think it costs a lot of money in order to do eye tracking? And second, last of all, can it be understood by anyone? So true, false, false. Yep, it is non-invasive, nice and easy. You just watch. Sometimes you can have big goggles on or glasses. Other times it can be like a little laser in the eye. Relatively easy. Is it expensive? Not really. It's quite a cheap process. It's getting cheaper and cheaper. And this technology is becoming more kind of used in other kind of scenarios, like VR glasses. Before, when you move around, it used to just kind of do based on your location. Now it will move the picture based on where your eyes are watching. And it's really interesting because, for instance, if your eye is directly looking at something, it'll make that super high definition, but the parts that it aren't looking at, it can make a bit more blurry and it can save more resourcing power. And once again, as always, can everyone understand it? No. So we're seeing a real thing here. While this technology is really, really interesting and has so many implications, we still don't really understand it. Only a few people do. It requires a lot of research, and still at the end of the day, it's not a direct science. It can tell us what is happening, but it cannot tell us why it's happening. This is why these tools, as great as they are, they cannot diagnose things like autism or dyslexia or ADHD yet. They can give us more information, but they can't give us the whole picture. Hence why we're still kind of doing diagnostics in a kind of like psychology way rather than using like tools like fMRI or kind of ERGs and things along those nature. So what are some key takeaways? And I know it's saying that this finishes way earlier than before. Well, it's a short subject because I did my back in and I'm knackered, but I wanted to give you a bit of a taste anyway today. So excuse the quickness of it, but hopefully still useful. So we learned that special tests can see how fast people react to help us understand what they like to buy. It can also show us what they're interested in. We also learned that our body has a system that controls how we respond to things. Remember our kind of internal things. So eyes, brains, lungs, like all of these help us monitor and they all relate to each other. We also learned that you can measure sweat and heart rate, and it can tell you how someone is feeling. Can't tell you what they're feeling, but it can tell you if they're feeling a lot or little. We can also track muscle movements with special tools, and we also can track eye movements. We can also, things we haven't covered today, we can also do kind of brain movement, how the brain is activating. There's so many other kind of methods. And we are using all of these in combinations in order to create a lot of studies. When we look at a lot of the research we have on neurodivergent conditions, such as autism, a lot of it is done via rat and mice models, and they do not directly translate. So there might be studies which say autistic mice show these qualities. Well, no, there aren't autistic mice, but what there are mice that have characteristics that are very similar to autism. And because we can't speak with a mice, we can say, okay, well, their blood pressure is going up, their eyes are tracking here. You know, you can do those things, and you can see how it correlates with humans. So again, while there's similarities where we can make educated assumptions, it doesn't tell us the whole picture. So there's pros and cons and limitations and strengths to any of these models. Now, to end off with, if any of you are neurodivergent and in the workplace, as well as giving these delightful webinars every week, we also do workplace needs assessments where we kind of support people with getting support, equipment training, and it's completely free to the individual. So if you are in the UK and are in employment, do get in contact because we can often get you like a good grant, which can help make life a little bit easier. Okay, now to Scribe. So we do these webinars all the week. We do these every week, and we'd love it if you can engage and keep this conversation going. Oh, thanks everyone. Will the video be available? Yes, Charlie. So April will be editing it, and she normally gets it up within a day or two. So yeah, definitely by next week, maybe a lot sooner. Thanks. Oh, really appreciate all your comments. Do you have a newsletter? Honestly, Charlie, we've tried and it's failed every time, but we are still working on it. The best way to keep in contact with us is via our social media like LinkedIn, Facebook, those sorts of things. Our next webinar, and this one will be really interesting to a lot of you from what you told me at the start of the day, is education and neuroscience. So today we talked about how do we get this information. The next webinar, we're going to be talking about how do we use this information. Now we've got all this fancy data on understanding how people's brains work, what attracts them, what disattracts them, where they're engaged, when they're not engaged. How do we take all this learnings and embed it into the education system, particularly now that we're moving from a different model of those who can do and those who can't do, where we're kind of basing on different abilities. So do check this out. Really great for anyone who does education or just understanding on how we can use all this information to hack the brain and get the best out of it. Oh, education neuroscience is everything. Nice. Have you done an event on the future of neuroscience? Yes, we have. So we have done events on the future of neurodiversity, the future of autism, ADHD, and we do have ones that I'm actually developing right now on the future of neuroscience. However, that will be probably later this year when we're actually delivering it. So it's in the pipeline. And here is our lovely LinkedIn community if you want to keep up to date with what we're doing. Nice and simple. And here is our contact details. If you want to know more, my name's Nat. So email me at nat@exceptionalindividuals.com. And I'll be more than happy to speak with you, get to know you, and help you where I'm able to. But thank you so much, everyone. It's been great having you as always. And I've loved the interaction today. And I really hope that you're able to get something from it. All right, everyone. Thanks so much. And hopefully see you next week.